We are going to be starting our conics unit. In order to do that, we're going to start by figuring out how to classify our conic sections and review the two conic sections you already know from geometry and algebra 2, the circle and parabola. Circles, ellipses, parabolas, and hyperbolas are all called conic sections. Because they are the cross sections formed when a double napped cone is sliced by a plane. So here we've got some figures showing that. When we've got our double napped cone here and we slice it from one side of one of the cones to the other, we end up with that circle there in the cone. If we slice this by a plane in this diagonal way from one side of the cone to the other, we end up with an ellipse. If we slice it parallel to our side here, then we end up with a parabola. And if we slice it to where it slices both cones, we end up with a hyperbola. Kind of looks like a parabola, but there's two sides of it. Here is one, and then here is the other. We'll see conic sections in real life in use in a lot of different things because of the reflective qualities that conics have. First, we'll start by matching which description of each conic section with its name. So a plane intersects exactly one nap and is perpendicular to its axis. That is the circle. A plane intersects both naps parallel to its axis. That's our hyperbola. Our hyperbola is the one that intersects both cones. A plane intersects one nap parallel to its element. That is our parabola. It is parallel right here, so it goes on forever because it's parallel, and this cone really extends forever here on all of them. And so that's where we get that parabola that continues on forever. Since this goes from one side of the cone to the other, the ellipse and the circle both are closed in, where the other two will go on forever. And then a plane intersects exactly one nap and is not perpendicular to the axis. That is our ellipse, the one that we do diagonally. It does close up though. There's that ellipse right there. It kind of looks like an oval. All right, you're going to love the general form of this equation. The equations of any conic section can be written in this general form. That is ax squared plus bxy plus cy squared plus dx plus EY plus F is equal to 0. That equation looks scary, but we actually don't use that one very often since it doesn't give us all of the information that we need. In this general form, A and C are not both 0. One of them could be 0, but not both of them. So we do have to have either an x squared or a y squared, and we're going to talk about those as we move in classifying those equations. But this is the general form there. F is the constant since it does not have the variables, and x and y are the variables in this equation. Our capital letters there are the coefficients. All right, so let's talk about classifying these by looking at these equations. We do have a little flow chart here to help you with that. The first thing you want to look at when you see these equations in the general form is either x squared or y squared missing? If the answer to that is yes, then our equation is for a parabola. The parabola has to have an x squared or a y squared. It cannot have both. Where our other three conic sections have both, the x squared and the y squared. Then is either x squared or y squared negative? If the answer to that is yes, then it is a hyperbola. For the hyperbola, the x squared or the y squared has to be negative. If the answer is no, we keep going to ourselves. Do x squared and y squared have the same coefficient? If x squared and y squared have the same coefficient, then our conic section is a circle. And do x squared and y squared have different coefficients, then it is an ellipse. So there's our options. When you get this general form of the equation, you should be able to look at it and identify which conic section we're talking about. So let's practice that. It says identify the type of conic section by looking at its equation. I look at the equation. The first thing I ask myself is either x squared or y squared missing. In this case, no, the x squared and y squared are both there. So I know it's not a parabola. The next question is either x squared or y squared negative? No, they're both positive. The next question, do x squared and y squared have the same coefficient? The answer to that question is yes. The x squared has a coefficient of 1 and the y squared has a coefficient of 1. So I know this is a circle. All right, we'll try another one and then I'll let you try some. I look at this second equation. I ask myself, is x squared or y squared missing? Nope. So that means it's not a parabola. Is either x squared or y squared negative? No, again, both of those are positive. Do x squared and y squared have the same coefficient? Nope. The coefficient on x squared is 4. The coefficient on y squared is 1. Do x squared and y squared have different coefficients? Yes. X squared has 4, y squared has 1. So this is an ellipse. So just by looking at the equation, I know what kind of conic section this is going to be. Go ahead and pause the video and try the other one. See if you can identify what each one of them are. And I'll keep going with a couple more. Y squared, on this next equation, I ask myself, is either x squared or y squared missing? Yes, in this case, there's no x squared. So this is a parabola. On our next one here, we've got an x squared and y squared. They're both positive and different coefficients. So that is an ellipse. Here we have a 9x squared and a negative yx squared. We've got both the x squared and the y squared, but one of them is negative. So that's a hyperbola. On number 6, we see the y squared is missing. So that's a parabola. On number 7, we've got both x squared and y squared, and they both have the same coefficient. So that is a circle. And on number 18, we've got a negative 4y squared. So that is a hyperbola. Hopefully you got all those correct. All right. So in order to know those conic section better, we're going to go ahead and review on some of the ones you learned. In geometry, you should have learned about the circle. Now with the circles, the equation of a circle is written as x minus h squared plus y minus k squared equals r squared. That means that they took an equation that looked like this, that circle, and they completed the squared and factored it in order to get it to this form. This standard form is much more useful. It gives us a lot of information that the general form doesn't give us. We'll practice getting it to that form in a little bit. But as we look at this right here, I said it gives us information. That's because if you look at this h and k, that's our center. So just by looking at the equation, I know where the center of the circle is. And this r squared that it's equal to is the radius. So r is equal to the radius. And with the center of a circle and a radius, I can graph it and get all the information I need from it. So let's look at some of those. On number 1, we've got an equation here, and there is a typo. It says r squared there, and that should have been 25. So if you'll fix that in your notes, please. So now we've got the graph of x minus 4 squared plus y plus 2 squared equals 25. So I want to pull the information from this equation that helps me graph it. We said the center is the h and k. Now, one of the things that confuses students is because of the sign here. Notice that the formula has a minus. So this minus is part of the formula. So the h is just the 4. And it should be y minus k, but it's y plus 2 here. That means that it had to be minus a negative 2. These two signs canceled out to give me the plus. So the k value is negative 2. So now we've got our center at 4, negative 2. And then our radius, this part right here is r squared. So in this case, our r would be 5 because the square root of 25 is 5. Now I can graph it. I go to 4, negative 2. And then I go 5 in every direction. Since the radius is from the center to the outside of the circle, I would go 1, 2, 3, 4, 5, 5, 5 up, and 5 down. And that creates my circle. So if I'm given the standard form, that gives me all the information I need. Knowing the standard form also allows me to write the equation of a circle. If I know its center is -8, -5, and we said that is H and K, you could get that from a graph, or you can be given that like this. And then our radius is the square root of 5. Well, I can just work backwards to plug that in here. I get X minus a -8 squared. Remember, we're doing minus the H. And then Y minus my K value, which is -5, is equal to my radius squared. Now I'm going to go ahead and simplify that. A minus negative, those two signs cancel out, and I get X plus 8. And then if these two signs cancel out, I get Y plus 5 squared, and the square and the square root cancel, and so we get 5 there. So that's my equation. X plus 8 squared plus Y plus 5 squared is equal to 5. If I were to multiply this all out, I would end up with that general form of the equation. And that's where we would go back to these longer forms that we see up here. So this is the standard form that's in that factored form, but if I multiplied it all out, I would get that general form. Which brings us to the third question here. It wants us to write the equation in standard form and identify the center and radius. So I told you earlier, when we're given this general form, it doesn't give me a lot of information. I can't get anything from here. I just know it's a circle, but that doesn't give me the center. That doesn't give me the radius. So I need to get it into the standard form in order to get that information. So we're going to do something that we've done before, and you did it hopefully in geometry as you did this. But in order to get it from this general form to the standard form, you have to complete the square. We're going to do that by getting our x's together and our y's together, everything else to the other side. So x squared plus 16x. Those are my two x's. And then I've got two y's. I've got the y squared plus 4y. Everything else goes to the other side. And so I've got a plus 2 here. So I'm going to subtract that 2 to get it to the other side. That allows me to get ready for the completing the square. Our ultimate goal is to have the equation look like this, which is the reason why I'm going to complete the square. This creates a perfect square trinomial. So if I make a perfect square trinomial here, it will factor to look like that. This too is a perfect square trinomial. So if I make a perfect square trinomial here, it will factor to look like that. So that's what we're going to do here. I'm going to find my missing piece that makes this a perfect square trinomial. So we get x squared plus 16x plus my blank plus y squared plus 4y plus my blank is equal to -2. Now, I'm going to add my missing terms here that make it a perfect square trinomial. So I need to do the same thing to the other side. Whatever we do to one side, we have to do to the other. That way we're keeping our equation balanced and we're not changing its value. All right, so what is this missing piece? Well, to find the missing piece that makes a perfect square trinomial, you take the middle term, divide it by 2, and then square it. So 16 divided by 2, sorry, I don't know why I just wrote that again. 16 divided by 2 is 8, squared is 64. And whatever I do to one side, I do to the other. Now I do the same thing for my y's. I'm going to take this middle term, divide it by 2. So 4 divided by 2 is 2, squared is 4. And whatever I do to one side, I do to the other. Believe it or not, we're almost there. Now that we've made these perfect square trinomials, we factor each one of them. So this is going to factor and this is going to factor. Now, since I made them perfect square trinomials, I know they're going to factor to be the same factors. To get x squared, that would be x. And then we're looking for what multiplies to be 64 and adds to be 16. And that's 8 and 8, which makes it the same factors. That's always going to be true if we made it a perfect square trinomial. So here, multiplies to be 4, adds to be 4, which is 2 and 2. So it's going to be the same factors again. That's always going to be what you divided this middle term to get the last term squared. So 16 divided by 2 is 8, squared is 64. Same thing here. 4 divided by 2 is 2, squared is 4. On this side, all we have to do is combine our like terms, and so we get 66. We now have the equation in standard form. And so we took it from that general form to that standard form. Now we can get all the information that we need. This is our h and k. So my h would be -8, my k would be -2, and this is radius squared. So my radius is the square root of 66. That's a perfectly good answer. You do not have to get a decimal approximation for that. All right, now we want to review the parabolas. Those you did in Algebra 2. So we're going to review those before we head off to the ones that we're going to learn in pre-cal, which is the ellipse and the hyperbola. So with parabolas, you should have learned the ones that open up and down and side to side. So conic sections can open the side to side. Those are the ones that you're not as used to. So here is our equations in the standard form. Just like the circle was centered at HK, our vertex is at HK for parabolas, which gets a little bit tricky because here the H is in the front, here the H is in the back. Let's look at why that is. Here we have an x minus h squared, and then the y is not squared. Here the y is squared and the x is not. That's important. The one that is squared is going to tell you which direction it opens. So x squared opens up and down. Y squared opens right and left. Remember when we were classifying those conic sections, if it was missing one of them, we knew it was a parabola. Here's why. The x squared gives us an up and down parabola. The y squared gives us a left and right. So on this other part right here where it says 4p, that's going to tell me whether it's up or down. If the 4p is positive, it is going to open up. If it is negative, it is going to open down. Same thing goes for this one. If the 4p is equal to negative, it is going to open to the left. And if it is positive, it is going to open to the right. So again, this standard form of the equation gives us all of our information. The HK is our vertex, and then the p-value tells us, the 4p, once it's simplified, tells us which direction it opens. There's a couple other things with these as well. Just make sure as you're getting that vertex, H is always with X and K is always with Y. So if you remember that when you're getting that vertex, then you won't get them confused. A lot of people want to do the first one for X and the second one for Y. That's not the way it works. The H is always with the X, the K is always with the Y. All right, so what is this P? Well, the P is the distance from the vertex to the focus and the vertex to the directrix. The focus is always on the inside of your parabola. So if it opens up, it's going to be on the inside there. If it opens down, it's going to be on the inside there. If it opens left, it would be inside. And if it was open right, it's inside as well. The vertex to the directrix. The directrix is on the outside of our parabola, and it is a line. So it's going to look something like this. So it is on the outside of your parabola. Focus on the inside, directrix on the outside. I told you the conic sections are important because of their reflective qualities. That's what this directrix and focus do. It assists in the directrix, in the reflective qualities. For those of you that think you don't see them anywhere, if you look up on the roof somewhere in your neighborhood, those satellite dishes, those are shaped as these conic section parabolas. That focus is that center transmitter part, and the directrix is on the outside to make sure that those reflective qualities occur. If you look at the front of your car, that right there is your headlight. The light bulb sits in the place of the focus. That's what allows you to have the reflective qualities of highlights and lowlights. And the list goes on. So these are important. All right, now we're going to look at some with all of their parts so that you can review them from Algebra 2. It says, from the given information, identify the requested characteristics. This first one here is x minus 3 squared equals 4 times y plus 6. The first thing I notice is that it is an x squared. If I multiplied this out, I would have an x squared. That tells me this parabola opens up or down. I then look at my 4p area right here. It is positive, so it is going to open up. This direction would be gone. The next thing I should get is the vertex. Remember, h is always with the x and k is always with the y. And just like with circles, it's supposed to be x minus h and y minus k. So if it's minus, that's part of the formula. If it's plus, it's because the two signs canceled out. 3, -6 would be the next thing I graph right here. And now it's time to graph my parabola. So this p-value, this simplified to be 4p. So in this case, 4p was 4. If I divide by 4, my p-value is 1. 4 times 1 gives me 4. So I am going to go 1 unit into my parabola, and that's where the focus is. Since this opens up, 1 unit in would be up from my vertex. So I go 1 unit, and there's my focus. The directrix, I would go 1 unit out, and that's where the line is. That is always going to be true. The distance between the directrix and the vertex is p, and from the vertex to the focus is always p as well. They have to be the same distance here. So our focus there is at 3, -5. Our directrix is a horizontal line. Horizontal lines are y equals, so that's going to be y equals, and it goes through the point -7. So that's y equals -7. All right, the last thing I need in order to graph it is the width of this parabola. Well, the width of a parabola is actually that 4p. So 4. This parabola is going to be 4 units wide through the focus. So I would go 2 units to the left and 2 units to the right. That's going to tell me how wide this parabola is. And then we just connect our dots. And there is our parabola. We are going to go ahead and try a sideways one so that you can review that part as well. It works exactly like the way we just did that one. So if you want to pause and try it, go ahead. I'll keep going. In this case, we have a y squared. So this is going to open left or right. The area where 4p is supposed to be is positive, so it's going to open to the right. The left goes away. So I know my parabola is going to look like this. Opens up to the right. Now I find my vertex. Remember, that's hk. H is always with the x. So my h value there is -3. My k value is -2. This is the one that students mess up a lot. They want to do -2, -3. Don't do that. H is always with the x, k is always with the y. So the x value is with the x, the y value is with the y. So -3, -2. There's my vertex. Now for the p here, 4p simplified to be 16. So my p value is 4. So I go 4 units into my parabola, and there is the focus. I move to the right this time because we said it opens to the right. So to be inside the parabola would be 4 units in there. Then I go 4 units out. And here is my directrix. In order for it to stay out of the parabola, that one has to be a vertical line, since this parabola is going to open left and right. Here we had a horizontal line since this opened up and down. The directrix is always on the outside. So focus is at 1, -2. And the directrix is a vertical line. So it's x equals, and it goes through the point -7. All right, for the width of my parabola, that is 16. That tells me how wide my parabola is. So I'm going to go 8 units up and 8 units down. That gives me a total of 16 right through the focus. And then I just connect my dots. And this one's a way wider parabola. And it opens to the right. So that's what our parabolas look like. That's how you get all the information from the equations. But just like with the circle, in some cases, you're given that equation in the general form. This does not give us any information. So we want to go ahead and change it to the standard form. And that looks like a 3 there, and it should be 2. Parabolas are squared. So if you'll fix that too. So we've got y squared minus 4y. So I put my y's together. Everything else goes to the other side. So I put this y squared and this negative 4y together. I'm going to send this to the other side. So it was positive 4x, so it's going to be a negative 4x on the other side. And since it was 0 here, then there's nothing else on this side. Now, just like with the circles, you're going to have to complete the square. With parabolas, it's actually easier because you only have to do it once. I can only complete the square on this side because that's the one that's got the squared and the y term by itself. So we find our missing piece to make it a perfect square trinomial. Whatever I do to one side, I'm going to do to the other. And now we start. We take our middle term, divide by 2. Negative 4 divided by 2 is negative 2. Squared is 4. Whatever I do to one side, I do to the other. Now I've got a perfect square trinomial, so I'm ready to factor that. Since it's a perfect square trinomial, I know it's going to be the same factors. To get the y squared, that's y. Then we're looking for what multiplies to be 4 and adds to be negative 4. It's always going to be half of that, so that's negative 2. On this side, we can't combine like terms, so it just looks like that. This almost looks like what we said was our standard form. I'm going to bring that down just so you can see it. This is our standard form. Right now, we already have the left-hand side. They're the same. On the right-hand side, notice that there's nothing in front of the x. It's been factored out. So that's actually my last step here. I need to factor out whatever's in front of the x. So I factor out a negative 4. Factor is just reversing the distribution. So negative 4 times x gives me negative 4x, and negative 4 times negative 1 gives me that positive 4. Now our equation is written in the standard form. Now we can pull all the information we need from it. Like it's a y squared. So I know left and right. Since it's negative, that means it's going to open to the left. My vertex, h is always with the x, k is always with the y. So this would be 1, 2. That means this point right here is at 1, 2. The p-value, this right here is negative 4, so we know that p had to be 1. A lot of people will write negative 1 there, but since p is a distance, it's actually the absolute values. So you don't have to write a negative 1 there. It's a distance, so you don't have to do that. 1 unit into the parabola would be our focus, and so that would be at 0, 2. If I went 1 unit to the left of 1, 2. And for the directrix would be 1 unit out. Vertical line, that's x equals, and 1 unit to the right of 1 is 2. So that was a lot. We did the identifying class conics and being able to identify which one it is from its general form. And then we reviewed circles from geometry and parabolas from Algebra 2. Hopefully you're really comfortable with that introduction. Next class, we're going to go ahead and do the ellipses.